You are listening to The Vocal Technologist. Spoken Tech for your ears.
All right, welcome in. Today we're going to get into something I think is on every engineer's mind. It's this feeling that your productivity gains are getting, well, sort of undone by these brand new, unexpected security flaws. And of course, why that cloud bill is still mysteriously, painfully high. It's a look at the massive shifts happening right under our feet.
That's a perfect way to put it. Our goal here is really to cut through all the chatter and pull out the most actionable and honestly the most surprising insights we've been seeing. We want to focus on where the crack of engineering is actually going. And that means looking past the AI hype and, right into the hard numbers, the performance benchmarks.
Right, the reality of it, not just the hype. So we've broken this down into a few parts. First, we'll hit the AI coding paradox. The huge gains, but also the terrifying new security model it brings. Then we'll jump into the web dev trenches. Framework fatigue, performance ceilings, all that good stuff. And after that, infrastructure, cost, and the big cloud migration question. And we'll finish up with a look at engineering culture and this idea of high agency. So let's start with AI, because the raw numbers we're seeing are, they're staggering. We're hearing reports that teams are getting a tenfold increase in just raw coding throughput, a 10x increase.
It's incredible. And it feels like we're solving the coding problem, right? But we're running headfirst into what you could call the building paradox.
Okay, what's the difference? Coding versus building?
Well, coding is just task execution. Writing a function, spitting out some boilerplate. Building requires integration, long-term thinking, maintainability, architectural vision. And the fascinating thing is the demand for hearing technical co-founders hasn't gone down at all. If anything, it's gone up. Because the AI can write the code, but it can't design the system. It doesn't see the big picture.
So the human role is shifting from just writing lines of code to being the architect, the integrator. But speaking of architecture, these new agentic systems have some pretty profound security risks, don't they?
They absolutely do. And the flaw is fundamental, is in the way LLMs are designed. They simply cannot separate instructions from the data they're reading.
So an attacker doesn't need to hack into the system. They just need to feed it something.
Exactly. They just embed malicious commands in content that the AI agent is supposed to read. Think about an AI summarizing user feedback. An attacker could hide a command inside a totally normal-looking support ticket.
Wait, in a Jira ticket?
In a Jira ticket. Or a hidden comment on a web page. If the agent reads that content and it has access to, say, a database or an API, well, the attacker is in.
Wow. So the very input the system relies on becomes the attack vector. How do you even start to mitigate that if it's baked into the LLM itself?
You have to accept the risk and then you isolate it. You build moats around the LLM. So you run the agents in sandbox containers, for one, and you have to be incredibly strict about what untrusted content it's allowed to see. And crucially, you split up the tasks. You never give one agent the keys to the entire kingdom.
That makes a lot of sense. And, even for engineers who are still writing code the old-fashioned way, especially in languages like Go, we saw some great reminders that the fundamentals still really matter.
Oh, absolutely. Good systems code is all about discipline. For instance, keeping your main functions absolutely minimal, pushing all the real complexity into well-tested packages.
Is that just for aesthetics? A minimal main function?
No. It's all about control and testability. It prevents those big monolithic code structures. And then there's using named constants instead of just scattering magic values all through the code. So much more maintainable.
And what about on the security side?
Well, preventing classic holes, like using OSRoot to stop a binary from snooping around files where it shouldn't, and critically, making sure your Go routines actually terminate properly.
Right, because if they don't, you start leaking resources.
Exactly. You're leaking file handles, database connections. The whole system just slowly grinds to a halt under load. You manage that with context and weight groups. The craft of it all still matters hugely.
So whether it's AI or human-written Go, structure is king. Okay, speaking of structure, let's pivot to the front end. It really feels like framework fatigue is hitting a new peak. We're seeing so much chatter about developers leaving Next.js.
There's a real frustration there. It's the growing complexity, the constant breaking changes. And, this feeling of being tightly coupled to Vercel's platform, the magic is starting to feel more like a curse when you have to debug it.
So if they're running away from that complexity, what are they running towards?
Frameworks like Tanstack Start are getting a lot of attention. The appeal is that it feels a lot closer to just vanilla React, but with all the modern stuff you need, like type-safe routing, but without the heavy vendor lock-in. It gives the power back to the developer.
And the real reason this matters so much is performance ceilings. There was this incredible analysis of a Kanban app built 10 different ways.
The results are just stark. You can't ignore them. The Next.js version loaded in about 467 milliseconds, but the newer, leaner frameworks like SolidStart or SvelteKit, they were loading in 35 to 39 milliseconds.
That's an order of magnitude.
It is, and it's a ceiling issue. The analysis showed that React has this unavoidable performance tax built right into its runtime. Even with an optimized setup like TanStack Start, the React version shipped 118 kilobytes. With Solid, it was just over 60. That's nearly double the overhead. You are paying a performance tax just by choosing React.
Wow. So framework choice isn't just about developer experience, it's about hitting a hard performance limit. Speaking of hitting limits, let's talk about that moment when perfect code fails in the worst possible way. That JavaScript security bug.
Ah, yes, the classic if statement bug.
Ugh.
So a developer had to check something simple like if,
Mm.
user authenticated,
Yeah.
a synchronous check. But then, because of a small change somewhere else, that function suddenly became asynchronous.
Oh no, so it started returning a promise.
It started returning a promise, and they forgot to await it. And in JavaScript, a promise object inside an if statement, it just evaluates to true, always, because it's a truthy object. So the security check was completely bypassed. Everyone got access.
Oof. I think every developer listening just felt a little shudder. We have all been there.
It's the kind of thing that makes you want to go back to writing Perl. It's a reminder that the runtime can betray you.
But let's end the front-end talk on a high note. Modern CSS is getting so good.
It really is. The new linear timing function is a game changer for animation. Instead of fiddling with weird Bezier curves, you can just define points on a line to create these really complex spring and bounce animations right in the CSS. No heavy JavaScript needed.
And we're finally seeing things like .has and container queries get wide adoption. You can build these really sophisticated, fluid layouts that used to be an absolute nightmare of media queries and hacks. The platform is catching up.
Okay, let's shift gears now to the money. The infrastructure, the big organizational moves. Amazon recently cut 14,000 corporate jobs. That's not just a small trim.
No, and the context is clear. They are cutting bureaucratic overhead to free up a ton of capital and resources to pour into AI. It's a strategic move, probably with a lot of investor pressure, to reposition for what's next.
And that cost pressure is forcing everyone to look at their biggest line item, the cloud bill. Which brings us to that amazing story from OneUptime. It's a fantastic case study. A real challenge to the cloud is always best dogma. They moved their entire operation off AWS and onto bare metal, using Micro K8s and Ceph. And they are now saving $1.2 million a year.
1.2 million a year.
A year. And this is the real kicker. They reported better reliability and lower latency than they had on AWS.
But what about the hidden costs? The people you have to hire to manage bare metal?
That's the question you have to ask. And it seems they found that when you factor in all of AWS's hidden costs, egress fees, control plane fees, just managing the constant change, it was actually more expensive than running their own stuff.
That's fascinating. And even for companies staying on the cloud, there are clever ways to cut costs. Nonit's solution for video processing was brilliant.
It was so elegant. They deal with a lot of short-term video data, so they built this custom landing zone in Rust, an in-memory buffer, to process the video before it ever hit S3.
And what did that do for the bill?
It completely eliminated the high-frequency put object request fees, those tiny charges you get every single time you write to S3, and it avoided the minimum storage duration costs. They turned S3 into just a fallback. It's all about targeting those microtransactions.
Such a great lesson. And this idea of choosing the right tool, not just the most complex one, seems to be a theme.
It is. We're seeing that a lot of organizations, even as they scale, can get by just fine using Postgres for their basic pub sub and queuing needs. This rush to adopt massive, complex systems like Kafka is often just premature. Postgres can handle more than people think.
That's a great practical nugget. And speaking of practical tips, here's one for everybody listening. Please avoid scheduling cron jobs at 2 or 3 in the morning.
Yes, the daylight saving time trap. It gets someone every single year. Your jobs will either run twice or not at all. Always use UTC for your scheduling. It sounds so obvious, but it's a real hazard.
Okay, let's pull the lens back a bit. Let's talk about career, about culture, this idea of high agency.
High agency. It's defined as the capacity to just take initiative and act decisively. And the argument is that this trait is way more important for success than just raw intelligence. Intelligence can lead to analysis paralysis, right? Overthinking everything. But agency is what drives action, what creates opportunities.
That's a really powerful distinction, and it ties directly into how managers lead their teams. You can crush that agency without even meaning to.
Oh, absolutely.
Yeah.
The confidence breakers are pretty clear. Micromanaging, criticizing people in public, always jumping in to solve problems for them. If you want to build agency, you give autonomy with clear guardrails. You praise in public, criticize in private. You mentor by asking questions, not giving answers.
And for those senior engineers, the principal ICs, the role changes too, right? It's not just about being the best coder anymore.
Exactly. You have to balance that deep technical work with a much broader vision. You're mentoring, you're setting technical direction, and critically, you're the one driving the hard projects that the organization would otherwise try to avoid.
So you're not just fixing the gnarliest bug, you're the person making sure the company finally tackles that 3-year-old architectural debt.
Precisely. You become the engine for the organization's long-term health. It's a huge shift.
And finally, communication culture. We all say we want transparency, but everyone still defaults to private DMs. Why is that?
It comes down to a few pressures. The pressure to perform, to sound perfect in public, the burden of having to add tons of context to every little thought, and just the vulnerability of admitting you don't know something in a public channel. The fix is cultural. Things like a no DM before public rule, or leaders just making a point of asking questions and showing that it's okay to be unsure.
So wrapping this all up, what's the takeaway for you? It seems clear. AI is making coders more productive, but it's the builders, the architects, who really have the leverage now. Performance ceilings are very real, so your framework choice matters more than you think. And sometimes the biggest savings come from questioning the dogma and maybe even hosting some things yourself. And that leads to one final thought for you to chew on. We so often build these incredibly complex systems, these sprawling microservices, that just happen to mirror our org chart. And it often leads to disaster. Technology sprawl, bad architecture. So if a simple tool like Postgres is powerful enough for our core data, and we're willing to take huge risks like leaving AWS to save money, why are we still designing distributed systems that prioritize the org chart over simple, sound architecture? How much complexity are we just accepting to avoid the discomfort of changing how our teams are structured?
That is a heavy question, and a really good one to end on, something to think about the next time you're on a whiteboard. Thanks for joining us for this exploration of what's happening in tech. We hope you can take some of these ideas and build something better, faster, and maybe a little cheaper.
Spoken Tech, for your ears.